So Raul, why don't you kick us off with the tech update?
All right, welcome to Community Update 218. So in terms of the
Ral,
progress,
I don't mean to interrupt, but it's good to have you back, man.
yeah, thank you. Thank you. It's been a hectic couple of weeks. So welcome to Community Update 218. In terms of the progress of the team in the last week, we have the two main things. As I said the last week, Tomislav and Greg have been working fairly regularly over the last week and a half or so to get the finalization design complete and verify that that covers everything needed for the simple protocol for finalization. Those sessions are complete, and Tomislav and NotZipper have been implementing the necessary changes and then testing them. They have a new testnet created for that. It's sort of like it's a new DevNet, I guess. And then also they're testing it on the simulator. The simulator has been modified to work with whatever variations there might be, they might be thinking about in the implementation paths. So that all is in place, and I think there's probably a few more days before the basic code for the simple protocol will be on this new testnet, and they're going to test it over there and on the simulator. And once it's working, they'll push it over to the 013 testnet. The other thing they've done in the process is that they've made the code much more modular and also more abstracted, so that if there are changes in one piece, that doesn't necessarily impact everything else, and that the overall validation and consensus flow can work fine. And if they need to change or modify any particular parts, they can do that and sort of independently of each other without having to have a whole lot of code spaghetti. You change one thing in one place and everything else needs to be changed or retested or thought through, all of that. So I think that's a very nice structure they have to the code there now. The one other piece, they're going to have to work on this first before they deal with issues around epoch change. Around the epoch change, there are a few more squirrely things they need to take into consideration in terms of figuring out what is the finalization fringe. I mean, obviously, in a decentralized system, there's always inconsistencies in state across validators, but there's a little bit more of that at the time of epoch change. So they're going to address those issues separately after they're done with this current simple protocol implementation for finalization. So that's the state of affairs there. And the other big piece that's been completed over the last week, Will and Dennis had been working, and Tomislav also put parts of this fix for multisig. So everything around multisig now seems to be complete in terms of it should be working fine. And the PRs are merged, and they're merged into both the RPC branch as well as the main branch. So all the necessary tests are added. So we should be ready to go with the multisig. I think a couple of them are still in review, but overall the work is done for the most part, and it's ready to go. That's where we are with that. And Stas has released, it's still work in process, but he's released the implementation of thread safe block receiver state. And this is something that's going to be used in the finalization fringe advancement. And this that work is also going on. Dennis has, he was working on the multisig piece with Will. He's now gotten back to looking into the performance improvement of the row-line primitives. He did look quite deeply inside that, and there are a couple of suspicious parts that they're looking into, but I don't want to say too much about that right now until he's done completing his analysis. So what he's doing is he's putting more detailed performance data, or he's generating more detailed performance data to understand the exact operations that are causing exponential delays. I mean, the linear delays probably are to be expected in many of these primitives, but really what he's looking for is where are we seeing exponential delays? And once we identify and finalize those, then the next thing is to examine whether those are implemented correctly and or whether they are being used correctly in the rest of that, because there may be some cases where the previous team may have taken an attitude of, oh, let's go ahead, sort this anyway. Maybe that's not required in some or many cases, that sort of thing. That's what we have to look at. So that work is going on. Max has implemented an alternative serialization for radix history using scodec, and is getting ready to measure the performance on that to see how much of an improvement we get. And if it seems like it's trouble-free and there is performance improvement, we will merge that into the code base. And the other stuff, we're continuing to work with external validators to get the network decentralized. We have at least a couple of parties that are actively working on the testnet and are running nodes on the testnet to learn how to run their validator nodes. So those are the main updates from me. And I think today, actually, Raphael wanted to do a demo of the multisig. Is Raphael on?
I do have a question concerning performance of the rolling primitives. I know that our RChain token makes use of the tree hash map instead of the primitive map. And that RPC is making use of regular maps instead of tree hash maps in conjunction with that. And I'm wondering if is there any idea of when we might know more about the expected improvements on the rolling primitives as opposed to the improvements that are obtainable from tree hash map?
Yes, I can speak to that. So Dennis's preliminary investigation shows what I expected and anticipated back in 2018, I guess it was 2019, which is what prompted me to go ahead and define the rolling 1.1 spec. So what we find is that there's just a lot of overhead, because a bunch of stuff that can and should remain in memory is going to RSpace. And every time it goes to RSpace, and every time we have any region of code that's communicating with any other region of code, it requires thread synchronization and then storage, along with being subject to consensus. And that's just not necessary if we just want one region of code to talk to another, and it's not part of an overall, it's not part of a transaction in the sense of, we know what we mean by transactional boundaries. So that's why rolling 1.1 exists, is because there's a bunch of stuff like just getting stuff into memory, getting stuff into a variable, so you can actually do some compute. That should not involve going to RSpace. And so we have added syntax that we will then extend the evaluator, the little interpreter, to accept that new syntax, right? So right now, what we have is a source-to-source translation, but that's not what's going to get the improvement. The improvement is going to be to extend the evaluator, it's called a reducer, to accept the new syntax, and then not go to RSpace for the new syntax. And that will then prevent like the massive slowdown, for example, when you're copying a map from one place to another. So my low ball was a 40% reduction. or 40% improvement in speed. Based on what we're seeing from Dennis's results, I think we could see an average of about 4x on a lot of Roland code.
So part of this solution is Roland 1.1, and I understand that bit.
And that's the dominant solution.
Is there more in addition to Roland 1.1?
No, really, that's the dominant solution. And that's why we kind of rolled Dennis off of, I mean, he's still doing some additional investigation, but the bulk of it is going to be Roland 1.1. Because once we have Roland 1.1, then we can implement a lot of these primitives in a much better way. And we won't touch the blockchain except when we need to.
Okay, and that cut is Roland 13. I'm sorry, Rnode 13.0, or is that hard fork 2? And
that's a post hard fork 2. Yeah, sorry. It's just like
okay.
there's no way we can at this point we're going to put modifying the reducer in front of hard fork 2.
Okay. I do have one other technical question. Are there plans to expose the parser and the interpreter to Roland code?
I would very much like the whole thing to be as reflective as possible. So we will take it under advisement. If you put an issue, an RChip into the into the system, we will consider it for sure. So it was certainly one of the things that we had in Rosette, and so I'm very familiar with its utility and would be more than happy to happy to support it.
Well. So I mean, I'm not sure if you've spoken to what I'm about to say now. Maybe you have, but RPC has plans to produce smart contract libraries side by side with the original code, and then verifying that the code being executed matches the smart contract that's stored for security sense, and so that people can see what they're actually executing on chain. And in order to do that, we need exposure of the parser and the interpreter, right?
Source is already stored on chain and it's signed, so I'm not sure why you need
Yeah,
to.
well, maybe this is a discussion for a different time. But
yeah, sounds good.
But we need access to the parser and the interpreter.
Certainly it makes sense to have those available. We have to talk about what it means to have those available in a blockchain context. But
yeah, I agree. It's a security risk. All right, I'm done.
Yeah. Anyway, yes. Let's talk about that in a design session.
Sure.
But thank you. So I wanted to clarify some comments that Raul made. So what we've done is to split the algorithm. Several months ago, I described the algorithm to the team, and I said, there's a simple version, and then there's a partitioned version. Write the simple version first, and then we will talk about the partitioned version. So NutZipper has had the simple version running in a private branch and under stress for quite some time. And what I said was just roll out the simple version to dev branch, and then to testnet, and then to mainnet. And then we'll go after the fancy partition version. So part of the delay is that the team wants to roll out a Cadillac before they roll out the Kia. And I've just told them, no, go ahead and get the Kia on the road, and then we'll roll out the Cadillac. And in particular, whatever we, I mean, unless of course there are errors in the code, but whatever we see from the simple version of the finalization algorithm will be optimal in the sense that any partition, what's the word? Any any logic that deals with the network running into a partition will only be an additional overhead. It will, so it ends up being what's the word? Sorry. It's a defense against the network running into troubles, right? So if somebody accidentally cuts a communication line somewhere, and half the servers can't see the other half of the servers, then the algorithm should handle that. And so we have the approach to do finalization, but that's much trickier than the simple version, which just requires that all the validators participate ultimately in the finalization. So first we're rolling out that simple version where all the validators participate in the finalization, and then we'll roll out the extra logic, which deals with what happens if the network hits a partition. And so that's what's happening. So it's not as if the conversations have completed, but they've completed for now, while the dev team is getting the simple version of the finalization out the door, which is something that they've had running now for months. So anyway, just a clarification there. Any questions about that?
So with the simple version, so it would still be leaderless in a sense that there won't be a round robin or anything like that.
No round robin, completely leaderless. It's just that if the network were to suddenly become severed in some way, we will, one side of the network will kick the other side out, saying you're late.
Gotcha. Mm-hmm.
Right. And so what should happen is they get parked as late, and then as long as they're within a particular window, they self-heal. So they say, oh, glad to see you. It's okay. No worries. Sorry you were late, and yeah, sorry we ran into traffic, blah, blah, blah. And then they do a reconciliation. So then they catch up and they both agree on what finalization looked like. Right. So that's what should happen. But in the case, in the simple version, the one side or the other will say, sorry, I've been sitting here waiting, and dinner's getting cold. You're late. So yeah, you're out this time. Come back next epic. Something like that.
Gotcha.
Does that make sense?
Yeah.
Okay. Okay, I see Raphael is there. Raphael, are you ready to give us a demo?
Yes. Okay, hello everyone, I'm Raphael, lead dev of the dappy project. So today I'll give a demo that is a follow-up from a previous demo on RChain multisigs. So it's not the same multisig that was referred to a bit earlier. Here we are talking about a multisig that has been developed by a 5-person group inside the RChain community. And it started, I guess, 4 months ago, and we have met every week or almost for those 4 months. So I'm going to present the progresses on those multisigs. So those are more higher level multisigs. So first of all, you can find the code on GitHub. It's under Fabcotech, the account of my company and RChain multisig. And so just to bring some context, a multisig is simply a smart contract or a location on the blockchain that is managed by multiple private keys instead of only one private key. So that's the definition, and we will see that the RChain multisig is a bit different than the ones on Ethereum, even if I don't know every implementation on Ethereum. But I'll just read this sentence because it gives a good idea how it works for RChain. So RChain multisig is a very simple multisig. Okay, there is a missing word. members can propose operations when at least 66% of the members propose the exact same operations in the same order. They are executed. So it is that simple, and that this is the demo that we will go through. So it is divided in 3 steps. First, we'll provide a general explanation, and then we will go on the workflow of 2 people participating to the same multisig. And then we will also close the loop and link the presentation with the work that is going on the dappy side. So let's get to the next one. So one cool thing on the RChain multisigs that we are developing is that the membership is liquid. It can change over time. I think that in many Ethereum implementations, when you create a multisig, you have to tell, hey, there are 5 members and we have to reach like 3 out of 5 for ETH to move. In RChain, it's it's different because you can invite new members and you can leave multisigs. So it's the membership is very flexible. Then we have recursiveness, so a multisig can be part of another multisig. This will be demoed. So from 1 to infinity. And we have this synchrony constraint, this threshold. So by default, it's 67%, but it can also change over time. Maybe the members want to require 90% as the new threshold, so they are able to do that as well. And on the right, we will get back to this slide because those are the current method that are available. So I have my local air node running. I have my my VS Code. So we are simply going to follow the steps one after another. And at the end of those 5 first steps, we should get into this situation. So I'm just, let's follow the readme.md. So first we have to deploy a mint. The mint includes all the code, and this way, anytime we want to deploy a new multisig, we just like instantiate the new multisig. So I just so I'm using a command line, so you can do all of those things with a handy command line. So I have my .env file that will keep track of what's going on. As you see, there is this variable multisig mint registry URI. So it has it just worked. And now let's deploy a multisig very simply. So by default, a multisig is empty. It has no member. And the rule is that the first member who comes is accepted. And once he is accepted, he represents 100% of the voting power. So he basically owns the multisig, and then he can accept new people. So we have done step 0. We have not done step 1 yet. So let's do this. We're going to apply as Bob. So Bob is going to apply. This is Bob's private key. And you see that right below there is Mike's private key. So Bob applies, and if we check the Roland logs, we should see, okay, first application will be automatically accepted. So now if we do node CLI read, we should see all the informations about the multisig, and we see that it has 1 member, Bob, and it also has a brand new rev address, so it can already receive funds. This is very cool. Okay, so Bob applied. he is accepted by default. And now Mike wants to apply as well. So I'm just going to switch this private key to use Mike's. And it's the same command, except that he wants to be called Mike in the multisig. He can use any pseudonym he wants, of course. Okay. So now we don't have the same log as before because the members of the multisig have to vote to accept Mike. So Bob has to accept Mike now. This is step 3. Okay, so we have to do a missing step. It's a bit complicated to explain what this step is, but keep simply in mind that the multisig is very, very modular. So all those operations on the right can be changed over the lifetime of a multisig. And right now we're going to kind of instantiate the default configuration. So Bob is going to do it because Mike cannot. So we're going to kind of set up the multisig. Okay. Okay, so now we are still at step 3. Bob has to accept Mike. And as I said, every decision has to follow the 67% rule. So anything you want to do in a multisig, you will just propose some operations, and you don't know if members will agree or not. But whether you want to transfer revs from the multisig, mint a new multisig, accept someone, you will just propose those operations, and other members will have to agree. So that is why so let's do node CLI read again. And we can see that there is this pending application. Mike wants to join. So Bob will now accept Mike. So we will do node CLI propose operations. And we will point to a file for the list of operations that Bob wants to propose. And let's check this one. So that's what Bob will propose. And since he is the only member of the multisig, of course, it will be executed. So Mike will be accepted. So let's get this file, operation.accept. I hope I'm right. Okay. So you can see that Bob has proposed those operations, and it should have worked. So Mike should now be a member of the multisig. Node CLI read. Okay, we have 2 members. So now Bob cannot accept someone by himself. He needs Mike to agree on everything. So this is becoming a true multisig. So we have completed step 4. So okay, so we don't have the one rev yet. This multisig does not have rev. So we're just going to very quickly send rev to the multisig. I have a script ready for that. Transfer rev. Of course, this is a rev address that does not belong to anyone. So no one knows the corresponding private key. It is generated in the Roland. So we have transferred rev. Let's do node CLI read again. Okay, our multisig has 1 rev. So Bob and Mike have this 1 rev fund under their controller. So now let's get to the next page. So we are in this configuration. A rectangle is just a multisig. So now step 5, Bob wants to mint a new multisig from the multisig that we are in. So we are going to show you recursiveness. So let's get this right the first time. So the Mint registry URI is this one. Okay. And so so Mike will propose, so should we do Bob or Mike first? I think it does not matter. So Bob will first propose, let me find it. Okay. Propose operation. Okay. So what Bob is about to do, you see that I have unlocked Bob's private key. He is about to propose that a new multisig is minted from multisig1. Let's do that. Okay. We have another command that allows us to check the pending operations. So read operations, member ID, Bob. Okay. Now it's not read operations, it's just operations. Okay, so this is a pending operation. It has not yet executed because only 50% of the multisig has proposed it. So now Bob will simply propose the exact same operation. Let's switch the private keys. Okay. Okay, so there is the comparison that occurred in the Roland, and everything executed right, and the multisig 1 instantly applied in the multisig 2. So now we do have this. So yeah, the operation has been reset when it is executed to avoid some replay attacks. So now let's do node CLI read again. So the membership has not changed, of course, but we have this new line, memberships in other multisigs. And the member ID of multisig 1 into multisig 2 is Mike and Bob. It makes sense. So we have done step 5, 6, 7. The new multisig is minted. And now we try to go quick, but we will transfer some rev from multisig 1 to multisig 2. And of course, Bob and Mike will do this. So let's, so instead of checking multisig 1, I'm going to check the data of multisig 2. So I do -r. Okay, so this is the rev address of multisig 2. And now, okay. So the new operations that will be proposed is just a rev transfer of half a rev from multisig 1 to multisig 2. So let's do that. Operation.transfer. So I think this is currently Mike that is proposing. Okay. Mike has proposed. Now Bob should propose as well. He proposed the same, so it will execute. Okay, operation did execute. So let's do node CLI read. This is multisig 1. It has lost half a rev. And let's read the second one. It has half a rev as well. And it has one member, Mike and Bob. So this is very cool. We have a recursive thing, and we'll get back to the presentation to see it in like yeah, graphs like this. So we are in this situation. We first did the first multisig, and this multisig is part of a second multisig. So anytime Bob and Mike want to do something here, they have to agree first. This is very cool. And now it's kind of strange because this multisig only has one member, but anyone can apply to this second multisig, and we could reach some configurations like this one, where instead of owning 100% of multisig 2, they have accepted some other members, and now this multisig 2 has 5 members. So now you have to get 4 out of 5 votes for anything that happens with the funds of multisig 2. Now, of course, multisig 2 can also mint a new multisig or join an existing one as well. We have not demoed the join, but you can join a multisig that already exists. So yeah, I have highlighted the colors in blue so you understand who is represented by which member. And of course, we can go in many directions from here. First of all, the multisigs could manage much larger funds, like 30,000 revs, for example. If we link them with the RChain token methods, they could handle NFTs. So it could be like a fund or an association that handles NFTs. They can handle any kind of fungible token, wrapped USDT or anything you want, like 10 million euros in this example. And the fun thing is that they can also manage dappy domain names, because dappy domain names are NFTs. So it's that simple. Everything is kind of unified. And as you can see here, we have some members that could be directly private keys. So those are real persons, but we can also have some members that if you look at who they are multisigs. So you have some hierarchical structures, and you can go up to any amount of members you want, of course. And this is yeah, the kind of the link to dappy. So in dappy we have dropped the DNS, and the name system is managed on the blockchain. And the cool thing is, since dappy names are NFTs, we can have multisigs that manage some TLD in the dappy name system, for example power DAO, but they can also allow some lower levels. So this is the second level domain, or the third, it depends on where you start, and this is the fourth, and each of them is managed by another set of members. So this can lead to very interesting trust models. So this is just I guess an exploration thing right now, but we'll keep exploring, and maybe we'll find some interesting things for governments, associations, companies, boards, etc. And yeah, I think that's it for today.
Thank you, Raphael. That was a great demo. I really appreciate that. There are obviously a lot of design possibilities. Is it difficult to go from 67% to K of N?
To what?
K of N. So, you know, like 3 out of 10 or 2 out of 5.
Oh yeah. No, I think it could be coded elegantly, but
nice. Yeah.
If I could chime in, the way we designed this was to enable governance. So right now, this percentage is not fixed. You can change it, and certainly the multisig can vote to change its own percentage. But we had in mind when we did this that multisig is a necessary part of governance, so that a consensus or agreement model in the future is pluggable So if you wanted to do ranked choice voting, for instance, in the future, it fits in here. This is the way we designed it from the beginning.
Wouldn't 30% be 3 of 10?
Yeah.
Yep, I guess.
Yeah. So when we're looking at this slide here that Raphael has up, if multisig 2 has a 30% agreement rate, then Bob and Mike and Jack and Mary can get together and multisig 2 will do something.
Correct.
And so what we recognized when we were going through this process was that multisigs are a necessary part of governance, but governance is a much broader umbrella on top of it.
Yes, agreed. Absolutely.
And we also recognized that if for an RPC perspective on this multisig system is the basis of blockchain permissions on files.
Sure. I mean, that's definitely a way to think about it for sure.
The other question is, it looks like Bob and Mike in your demo, they don't have control over who could join the inner multisig. But one way to think about being an inner multisig is that Bob and Mike are a filter on who's allowed to join. So that's, I mean, you know, your design is coherent and logical, but we might also explore another design space in which the meaning of being inside of another boundary is that whatever goes on inside the boundary is controlled by those parties who are on the wrapping boundary.
Yeah, and now you get into the mathematical set theory of multisigs.
Yeah, I mean, I'm just saying.
Where is the overlap and where it is, and yes, there's a lot of exploration in there.
There's a lot of big, huge design space. Great demo. Thank you very much, Raphael. We only have about 15 minutes left. So unless there are any burning questions for Raphael, I would like to move on to Daryl's Week in Review.
Yeah, this is a 5 person's work, or even 6, I guess.
Excellent. I mean, that's the other thing that's really amazing is we're starting to see some interaction within the community and rich features being developed on top of RChain. One quick question: how large is the Roline code?
I think it's not that large, so 10 seconds and we should know. So this is 400, and yeah, then we only have this, so this is 600.
Okay, there we go. There we go. Fantastic. That's what I love to see. Functionality as crucial and vital in terms of governance and other things as this in 600 lines of code. Fantastic. Awesome. All right, Daryl, you up?
Oh yeah, I'm here. Yeah, that was exciting, Raphael. I love it when Greg always asks the question at the end, like, how long did it take you to build this? How much code was that? That's awesome. Okay, so here's the Community Week in Review for last Thursday, March 31st to today, April 6th. So on Friday in the Climate Coordination RCast, we discussed the destruction of the Conger Glacier in Antarctica and the Thwaites Glacier, which is in danger of collapsing and raising global sea level by 0.5 meters. We also discussed wind and solar surpassing 10% of global energy sourcing, and a piece in The Guardian about crypto energy use and fossil fuel dependency. Let's see, on Saturday in the RGov smart contract call, they discussed patterns of cooperation without vulnerability, putting RChain financials on RChain. They discussed RDrive review and discussion and cross-chain capability transport using row types. On Monday's Casper stand-up, It covered the last mile and what's needed to ensure the OSLF calculation delivers a collection of the specified input to the algorithm, rather than from the ambient category where the domain equation for the predicates is solved. On Tuesday in the communications working group, it was mainly a working session where we focused on drafting a press release to coincide with the Paris Blockchain Week. And this morning in the RChain active member hangout, we discussed Jim's upcoming surgery scheduled for Tuesday, which led to a discussion of universal healthcare versus non-universal healthcare, which brought us into a politics discussion, yikes, and eventually led us to discussing, or more accurately, Steve Henley explaining to me the two-part Casper stand-ups from March 1st and March 7th that Steve believes should be in Greg's greatest hits collection, regarding the view of token systems as seen as chemical or biological structures. And you can see those Casper stand-ups. If you just Google Casper stand-up, you will see them March 1st and March 7th. And that brings us to now.
Thank you very much, Daryl. Any questions on the community debrief? Okay, I will give a quick update on the board meeting. The board did vote on 5 resolutions. One of them was a gimme. It was just approving the minutes from a previous date. But the other 4 were material. Some time ago, the board instructed the executive, that would be me, to convert the 2 social purpose corporations that are our subsidiaries to LCAs. I then spoke with the Secretary of State of Washington, the office that is, and discovered that you can't convert an LCA to, you can't convert a social purpose corporation, an SPC, to an LCA, but you can convert an SPC to a co-op, and you can convert a co-op to an LCA. So the board has instructed the executive to convert both Dazzle and RPC to co-ops, and then on the success of that transition, convert them to LCAs. So it's a lot of paperwork and gyrations full of sound and fury, but we have to get that all done, and there's time pressure to get that done. So that's what those resolutions are all about. Any questions on that matter?
Is there an expectation on the time frame? Is there a deadline for those resolutions?
I mean, the resolutions don't mention a deadline, but we are working under a time pressure. So I am moving as fast as the Secretary of State of Washington will move.
Oh my God, they're going on vacation soon, aren't they?
They'll probably take some time off for Easter, right?
Yeah. All right. Just curious.
Yeah. Okay. I think that about covers it. Any other questions, comments, concerns, jokes from the community?
Since there are a few minutes here, I think I have invented a word, and this may not be entirely appropriate for this forum, but I think the word SEQUID should exist. And it is an adjective that describes the inaccurate measurement of intangible things.
Okay. There we go.
So I'll throw that out there.
Send it off to J.K. Rowling. She could do something.
That might be an interesting idea. I think I'll give that a try.
Cool. Any other questions, comments, concerns? This is your time as much as it is ours. Okay, thank you very much. Looking forward to a fun time in Paris. I have draft slides that we'll be presenting in the closed door session on Friday. There is other news that we'll be making available in the closed door session. And so if you want to hear about that, please show up on Friday. Thanks to all. Please stay safe.
A quick question, Greg. Since Paris is happening next Wednesday, will this meeting happen next Wednesday?
This meeting will be at 9 in the evening or 10 in the evening in Paris. So yeah, probably.
Okay.
Yeah. Awesome. Thanks all. Please stay safe, stay warm, and we'll see you on the other side.